Greetings. I'm Dr. Tom Brassu, Dr. B to most of my students, and this is the first of a series of sessions to review basic Python facilities. In particular, this video and a companion video will discuss lists in Python and the basic operations that allow us to get the most out of those lists. So when we think about lists, we can view it from the perspective of what is the abstraction that this construction is allowing us to obtain, and then what is the specific interface which has to do with what are the operations that are supported and the syntax and semantics of those operations. Now, like a lot of the things that we do in computer science, lists is a pretty simple abstraction that we're familiar with from real life. So, for instance, if I have a list where I've got eggs, bread, and milk, that's a list with 3 items. So there's a length to the list, which is equal to 3 in this case. And the idea of a list is that it is a collection, but also that it has some order to it. By that I mean eggs is the first thing on the list. Bread is the second thing on the list. Milk is the last thing on the list. And so order implies 2 things. One is that every item except the last has a successor, a next item in the list. So the successor to eggs is bread. The successor to bread is milk. There is no successor to milk. And correspondingly, every item except the first has a predecessor. So the predecessor of milk is bread, the predecessor of bread is eggs, and there is no predecessor for eggs. All right. With this idea that we have an order allows us to name the things based on the order. Now, this is already familiar to us. We talk about in English the first item on the list, the second item on the list, the third item on the list. But in computer science, we want to be more efficient than that. We want to name things using an integer that specifies their position. We call that the index. So instead of these bullet points, we'll erase those and we'll add in this idea of an index. And we're going to use an index that starts at 0. So index 0 refers to the eggs element. Index 1 refers to the bread element. Index 2 refers to the milk element. Right? So our index allows us to say what item we're talking about in a list in an efficient way. Right? Now, one of the things about lists in a lot of domains is that the item itself might be repeated. We might have an item 3 that also has value eggs. That's perfectly legal in the abstraction that we're talking about. All right, so we can have multiple items at, uh, with the same value at different positions in the list. One of the things that makes this interesting is that we've got to be careful about when we modify the list, the index needs to change. All right, so say that I take a look at this list and I say, I need to add ice cream. And for whatever reason, I decide that ice cream is going to be between position 1 and the current position 2. Well, in order to do that, I need to take the current position 2 and 3 and kind of move them down, so to speak. And then I'm going to put ice cream in the position that I want it. But that means that in order for this index to refer to the order of the collection, ice cream becomes 2, and milk, which was 2, becomes index 3, and eggs, which was index 3, becomes index 4. All right, that's the basic premise of the abstraction that we're dealing with. Right? So a couple of terms that we've used, let's try and make precise here. This integer that's used to map from the integer to a particular item, we're calling the index. We also use the word position. Right? The set of things that are in the list are called the items of the list, also sometimes called the elements of the list. A list can be empty. It can have no items at all, in which case the length of the list is 0, but in general, the length of the list is the number of items that are in that list. And because we're using an index that starts at 0, it is always going to be the case that the index of the last item is going to be equal to the value of the length minus 1. Or if I know the index of the last item, I can add 1 to it, and that gives me the length of the list. In order to understand what we can do with a list, our attention needs to turn to the operations on a list. All right, we're still dealing in the abstract. We're going to make this concrete with Python examples, but we first want to understand the abstraction. So first of all, operations include constructing a list. What is the syntax that I use in order to create a list to begin with, whether it be an empty list or a list that has some set of initial values in it? Second, if I have a list, how do I refer to any of the individual items in the list? Or how do I refer to a subset of the items in the list? That's called access. And so under access, I want to be able to access a single element, but I also might want to access a sublist. Right. Once we have the construction and the access, then the other operations that are of interest to us are the ones that change a list. All right. Those are called the mutators. And depending on the programming language and the operations supported by a list abstraction in that programming language, there can be a lot of different varieties of these. Right? It sometimes causes some of the confusion, right? But we may want to, for instance, change an existing value. All right, so in my example up here, I might want to take bread and I want to change that to bagels. All right, so I want to replace an existing element with a different element at that same position. All right, I may want to, like I did with ice cream, I may want to insert, which is going to cause the index of the elements that are after that insertion point to change, to drop or add by one. Right? I may want to remove an element. So say that I want to get rid of milk. I may want eggs, bagels, ice cream, and eggs to be the list and to eliminate milk. Um, we may want to also do variations on search. I may want to ask the question, is an element, some value that I have, present in the list? That's one type of search. Because I need to work with the elements themselves, often I may need to say, not just is it present, but what is the index of this value within the list? Or something might occur more than once in a list. Eggs, in the example that we've got here, I may want to ask the question, how many times does this value appear in this list? These are all variations on search. Okay, so those are the four main categories of operations. And now we're about ready to transition and ask ourselves, okay, for Python, how do we actually do this? What is the syntactic elements that we need to use? What are the operators and their operands? Or in the case of an object-oriented language like Python, what are the object methods and their arguments in order to affect these various operations? All right. I'm going to pause now, and then we'll come back. Now, when we come back, what we're going to do is to use what's called Python Tutor, and this gives us a way to visualize what each of these things does. Okay, I'm back. The screen that you see in front of you is a Jupyter notebook. So if you're not familiar with Jupyter notebooks, these allow both documentation and cells that allow code execution. And so I'm using this to show code exemplifying the syntax of the various operations for lists as part of this lists review. So we'll have a cell, and then after each cell that has a set of code, and we can execute the cell and look at the values, I also have a link that's called the cell visualization that allows us to go to the Python tutor and be able to walk through each of the steps of the Python in the cell and understand exactly what they're doing. All right. This list introduction, all right, if I take a look, I've got listintroduction.ipynb at the top of this. This should be available to you in the same place that you found this video. All right, so when we talked about the operations, we said we've got to be able to construct lists to begin with. And I also will use this review to be able to talk about tuples, which are a really, really close cousin to lists. So in the list construction, so we're here in construction and then we're here in lists, we see that I am first creating an empty list. Then I'm creating a list with 3 string items in it. Then I'm defining some Python variables to refer to those same string values, and I'm using that to construct a list. And then to show a list of integers, I'm using an integer value and some expressions that make up the items in a list of integers. All right, so let's take a look at the cell visualization. And in the Python tutor, we get a place where we can edit. And so I strongly, strongly, strongly encourage you to not just follow along, but try things for yourselves. One of the reasons I'm giving you, these resources, including these links, is that you can change this to be anything that you want. So I could use 0, 1, 2 as the values in this first list. All right, so especially if you're not sure of something, try it for yourself and see what the effect of those changes that you make will have, and that will help you better understand what's going on. Right? Once we're in this edit page and we're satisfied that we want to go ahead and visualize the execution of these 8 statements in this case, we click on Visualize Execution. There are also some ways of changing the default values and how they're displayed, but we're going to go with the defaults in this particular case. All right, so if I visualize execution, I'm going to get a screen that shows me my code on the left-hand side. And then on the right-hand side, I see frames and objects. Depending on your instruction in an introductory course, the objects are the values in my Python program. Right? And so we're going to see the data itself there. And on frames, that's how I name items. So there's a global frame that has to do with all of the names that are accessible to me, even if I'm not in a function. And then if I invoke a function, then I have a narrower frame, a more constrained frame that's going to have the names that are defined when I'm in a function. We'll worry about functions later. That's a different review topic. Down below the code, I have navigation that allows me to go a step at a time, which is what next does. It allows me to go to the very end, which is what last does. I can be partway through execution and I might say, hey, back up a step. I can use previous in order to go back up a step, or I can use first to go back to the beginning. All right, so let's create the first list by saying next here. And over here on the right, you see that my list 0 is the name in the global frame that refers to a value in this object space, and that value is an empty list. Okay, my list 1, we're going to expect the same kind of thing, that I'm going to create in the global frame another name, my list 1, and it's going to refer to in the object side, the right-hand side of that right-hand panel, a list that contains those 3 items. Okay, I click Next, and that's indeed what I get. Let me widen this a little bit so that you can see all of it. Eggs, milk, and bread. Now, the next 3 statements are simply creating Python variables, v1, v2, and v3, that refer to those same string names, eggs, milk, and bread. And now my list 2 is constructed, and instead of using constant literals, we're using the values of variables. So each of these variables gets evaluated. What is the value of v3? The value of v3 is the string bread, as that becomes the first element of my list 2, and so forth. So my list 2 refers to breads, eggs, milk. And you can see in the depiction here that in the top left of each of the cells of the list, I've got the index or the position. Position 0, position 1, position 2. I create an integer variable named x with value 4, and then I create my list 3. And again, each of the elements of the list, when I construct it, I evaluate each. So x evaluates to 4. 3 is a constant that evaluates to 3. X minus 2, given that x has current value 4, I subtract 2 from that. That gives me value 2. That becomes my third element. And the integer constant 1 has value 1. That's the value for it. And that then gives me the set of values in the constructed list. Oops. Sorry, I hit the edit this code instead of next for that very last step. And there you see 4, 3, 2, 1 as the set of values in the list referred to by the variable mylist3. Now, when we're speaking, we'll just say things like create a list with the values 4 down to 1 and name it mylist3. But what's really happening is mylist3 is a variable that refers to this list data structure that sits in the value or object space. Right, that's my first example of creating lists. If I close that visualization and I'm back to my IPython notebook, the next is a simple example that does exactly the same thing, only this time instead of constructing lists, we're constructing tuples. Syntactically, what we see is that instead of the square brackets that help us to define the construction of a list, we use parentheses, begin parentheses to start a tuple construction and end parentheses to denote the end. Just like with lists, we use comma separated items to define the items that are within the list. The visualization of this, I'll go relatively quickly. The only thing that we're seeing different here is that my tuple 0 refers to an empty tuple, whereas in the last example, it referred to an empty list. My tuple 1, again, I'm told the data type at the beginning, and it's a tuple instead of a list, but the content looks exactly the same. The construction of the rest follows exactly. It's just that the data type is tuple. And syntactically, we use parentheses instead of square brackets. For this first video, the next thing and the last thing that I'm going to talk about is access. So the idea that if I've got a list, how do I obtain the value associated with a particular position? And globally, not globally, generally, how do I refer to a subsequence of a list or a tuple? Again, tuples and lists look almost identical. All right, so in this example, before I go to the visualization, let's take a look at the code here. I'm starting with initializing my integer x to 4, and my list 3 is x, 3, x minus 2, 1. So kind of picking up where we left off in the construction. So I've constructed a list. And then my first example is using expressions where after the name of the list, my list 3, I have begin bracket, an integer, an end bracket, and the value of the integer in between the brackets is the position. Right? That's the most basic way that I can go from this mapping that takes me from an integer to the value associated with that element of the list. All right, so that's going to print the index 3 and the index 0 items of that list in that order on the print statement. Right? Then I create a second collection. In this case, I'm going to create a tuple. All right, we know that by the begin and end parens. And then I'm going to use that and construct an an integer index that starts at the last valid value. And then I use a while loop in order to descend through the elements in my tuple 3. I'm going to construct my list 4 by taking a range and converting that to a list. So that's going to give me the set of integer values that start at 5 and go up to, but not including 10. So namely 5, 6, 7, 8, 9. And then I can use that as the list and use access operator with index 1 to get a particular value from that. More of that as we go through and look at the visualization. All right, I construct my first list. Then the print with my list 3 sub 3 and my list 3 sub 0 is going to print those two values in this area here. So note that we've added a region to the right-hand side, the effects of our code, that is the print output. All right? So my list 3 is the name of my list, and I use the square brackets and the 3. So in this case, the square brackets are not the same thing as the constructor operator, but rather these are called the access operator. The access operator allows me to put an integer as the value inside between the two square brackets, and that indicates the position. So I get 1 and 4, which is what I would expect. All right, I continue through, excuse me, and talk about V1, V2, and V3, and then create a tuple. And one of the reasons for showing tuples here is that we use parens for the constructor of a tuple, but we use the exact same access operator, the square brackets, when we're accessing an element of a tuple. Right? So I'm going to set up I as the index of the last item. Right? So my indices are 0, 1, 2. I starts at 2, and I'm going to have I go down to and including 0 in this while loop, and print my tuple sub I. Now note the wording that I use. When I'm talking about a list and then an individual element within the list, my English language is saying it's sub I or sub 3 or sub 0. This is intentionally trying to relate us back to the idea of a mathematical subscript. A mathematical subscript serves the exact same rationale as an integer position in a list. It gives us a way of naming or referring to an element. Okay. All right. So when I is greater than or equal to 0, because 2 is greater than or equal to 0, and I'm going to print my tuple sub I, and so I get milk, the last thing in the list. Decrement I is now 1. It's still greater than or equal to 0, and I'll print my tuple sub 1, and that gets me eggs printed to the print output. And then finally, I goes to 0. I don't know why it popped out. We'll get back to that same spot. And now I is 0. It's still greater than or equal to 0. And then I'll print out the first item or bread. Okay, line 16 is simply a way of saying I can have an expression. This expression here, list with argument range 5 to 10, gives me a list, right? It's a way of creating a list using a range. And so line 16 is simply showing me what that list looks like. But line 18 is actually going to use that same expression that's on the right-hand side of the assignment in line 16, and then I'm going to issue or use the access operator on that list, right? So one way of saying what's going on is that this expression here is a list, right? Anytime I've got a list, I can follow that with an access operator and then an integer in that access operator that says, what element of that list am I interested in? This is just demonstrating something we should have already gotten from our intro classes, that we can compose these things together. If I've got an item of the right type, in this case, a list object, which is what list of range 5, 10 gives me, then I can apply an operator to that, and I don't have to use an intermediate variable like mylist4 in this example. And then we print the value that we got in that assignment. I could even put this entire expression, list range 5, 10, begin bracket, 1, end bracket, in place of y right here. There's no reason why that print has to be to a single variable. I can have as complex an expression as I want or need in that print. That composability is part of what gives us power in a programming language to do the kinds of things that we want to do to solve the kinds of problems that we're after. Okay, one more set of things where instead of getting a single element, we want to get a sublist. So we start with the idea of a contiguous sublist. So we know this is slicing, right, where we get to specify, along with the access operator that says we want to do this on a particular list, we get to specify the set of indices that we're interested in instead of just a single index that we're interested in. Right? So in the example here, I create a list, I print it, and then we're going to use A and B as variables that we're able to specify the sublist. I'm going to go straight to the visualization for this. All right, construct the list. And so it starts with the value 9 at index 0 and goes and has value 7 at the last index, which is index 11. It's a 12-element list. All right, I print the list, then set up A and B. In line 7, we are specifying inside the access operator A colon B. So Python uses colon in order to identify syntactically a slice. A slice has the value, implicit or explicit, before the colon. That's the start index for the set of items. Then implicitly or explicitly after the colon is an index for the end. But as you probably learned from your intro class, we include the beginning and we go up to but not including the end. So in line 7, we're saying, give me the sublist of my list 5 that starts at index 3 and goes up to but not including index 7. Right? If we step through, we'll see that's exactly what we get. Right? So if I think about the slice, 3 and 7, what we're kind of saying is, okay, draw a line here that starts at 3 and then draw a line where I've got the 7. We're going to go up to, but not including that item there. And so that's exactly what we get as a result. If I omit the value before the colon, then that implicitly means index 0 or the beginning of the list. And so line 8 is saying go from the beginning of the list and go up to, but not including the value of A, which is 3. So that's essentially saying, whoops, we're going from the beginning of the list up to, but not including the 3. And so that should give me the sublist that has 9, 12, 1. I execute that, and that's indeed what I get for L2. Similarly, if similarly as line 10. In line 9, I'm doing a similar kind of thing, but instead of the go up to but not including, the end value is given by the variable b, and so that's going to be from the beginning of the list up to but not including the 7, and so that should start with 9 and end with the first 21. And then finally in line 10, we're using a slice that starts at B, which is 7, and does not specify a value after the colon. And so that implicitly means the end of the list. All right, so starting from B or 7 and going to the end of the list is going to start here and go up to the end of the list, and that will include the end of the list itself. So that's why we don't use 11. It's actually kind of this almost virtual 12, or the length of the list. Okay, that's the nutshell of slicing. Now, for all of those cases, we were looking at contiguous sequence within the list. So a sublist pattern 1, slicing is even more powerful than that. In addition to the value before the colon, specifying the start, the value after the colon, specifying the up to but not including index, we can use another colon and specify what's called a step. Right? That governs how do I go from one index that's part of the sublist that I'm generating to the next. By default, we go one more, okay? Every time if I started at 3 and was going up to but not including 7, I'd have 3, and then plus 1 to that would be 4, and 4 plus 1 to that would be 5, and 5 plus 1 to that would be 6, and 6 plus 1 to that would be 7, but that's my not including value, and so I stop. All right, so let's visualize that. Starting with the same list. Now, in addition to A and B, I'm going to have C, which I'm going to use in some instances to say, how do I go from one index to the next as I'm determining the set of things to include in this sublist? All right, so L1 says, go from 3 up to, but not including 7, and at each index that's included, to get to the next one, I'm going to add 2 to it, the value of C. All right, so that means that I am going to start at 3, all right, and then I'm going to add 2 to it. So after 3, I go to 5, and then I add 2 to that, and I get to 7, but 7 is the value that I go up to, but not including, and so I'm going to end up with 3 and then 5. which gives me the subsequence 1422. All right, let's take a look at L2. Even when I have that step value, that third value interspersed with the colons, I can still omit the beginning, in which case it means the beginning of the list entirely. Right? So starting at index 0 and going up to but not including index 7 in steps of 2 is defining the set of positions to be included in L2. And that's 9 and 1. All right. And L3 is 9, 1, 9, and 21. And I can also omit the end position. So I'm going to start at B. I'm going to go up to the end of the list, and I'm going in steps of 2. So that's going to go from 7 through the end of the list in steps of 2, which is 21, 17, and 7. My last example considers when we want to go in a step that's not positive. So the default step is 1. I go from 1 index to the subsequent index. When the step is positive and not 1, then I add that number to each value. But I can also use a negative step in order to go the opposite direction in a list. Right? So sublist pattern 2 is set up nearly the same. All right, so let's go to the visualization. Now we're going to visualize what happens with a negative step value in a slice. All right, so we start with the same list, my list 5. A is still 3, B is still 7, but C, the value that we'll, in a couple of cases, use for the step of the slice, is negative 2. All right, and so if we visualize execution here, line 8 is saying start at, now notice that I'm starting at 3, I'm going up to 7 in steps of -2. Well, if I start from 3 and I go up to 7, but I'm going in negative steps, well then I don't have any indices that satisfy that A colon B colon C, because B 7 is greater than 3. And so there's no way of using a -2 step to go from 3 to get to 7. Right? And so this is there to show you that if I invert the indices, and if I'm using a negative step, then I get an empty list as a result. What I really wanted to do was to start at 7, all right, and that's the including. Right? I want to start at 7, and then I want to go backwards and get 5, and then I would get to 3, but that's my not including, so I'd get 21 followed by 22. Right? Try this for yourself. If that's not clear, you really need to try these kinds of things to yourself. All right. 21, all right, that was the index 7 item, and then 22, that was the index 5 item. All right. Showing some permutations, the rules continue to apply exactly the same. I'm going to have -1 as the value of my step. And where am I starting? I'm starting at A, all right, 3, and I'm going to go to the beginning. So now if I've got a negative step, the second value is where I stop. And if it's omitted, it's the beginning. And so this is going to give me a descending list starting at 3. So I'm going to get 3, 2, 1, 0 as index positions. Indeed, I get 14, then 1, then 12, then 9 in the result. Right? If I don't specify the beginning and I don't specify the end and I use a negative step, well, the beginning must be the largest valid index. I'm going to start at index 11 and I'm going to go by steps of -1 each time up through the beginning of the list. So line 13 is a really easy way to get the reverse of a list. Right? 7, 1, 17, and so forth until I get to the first item of 9. And L4 shows what happens if I don't specify where I begin. And I'm using a negative step, so that's referring to the end of the list, 11. And I'm going to go up to, but not including 7, in steps of -2. So that's going to get me index 11 and index 9. So the value, um, 7 and then 17. Oh, okay. That's exactly right. We're talking about the original list. My pause was because I was looking at L3 that we just created, and I should have been looking at my list 5. Okay, I think that wraps it for this first list review video. All right, so that's all about constructing lists and constructing tuples and accessing individual elements and accessing slices. All of this should be review, but practice with it. Use those visualizations, use something like the Jupyter notebooks in order to try out variations until you feel like you really understand this. All right, thanks.